Okay, so get this. Today we're diving into something that's, well, kind of wild. We're talking about the flat Earth theory. Yeah, the idea that our planet is like a giant pancake just floating around in space.
You're kidding, right?
Nope, totally serious. Crazy as it sounds, some folks really believe it, even though we've known Earth is round for over 2,000 years.
2,000 years, wow.
Right. So in this deep dive, we're going to look at all the evidence that proves Earth is round, from ancient discoveries to like satellite pictures and stuff.
Okay, that makes sense.
But we're also going to try to figure out why this flat Earth idea just won't go away. Like, I remember one time, my uncle got totally convinced we were all being lied to about the Earth's shape.
Oh, no, really?
Yeah, Thanksgiving dinner got pretty interesting that year. He even tried to show me this YouTube video as, like, proof.
I can only imagine.
It's wild, right?
It really is. It's amazing to me how a basic fact about our world is still, up for debate for some people.
I know. It's mind-blowing. But you're right. The evidence for a round Earth is like a mountain high. And it's a story that goes way back in time.
Definitely.
Like way, way back. Think about it. Back then, no telescopes, no spaceships, no nothing. How would you even begin to figure out what shape the Earth is?
It does seem impossible, doesn't it?
Totally.
But the ancient Greeks, they were pretty sharp.
The Greeks.
Yeah. Pythagoras, for instance, he watched how the stars and planets moved, and from that, he figured out that the Earth must be a sphere too, just like all those other celestial bodies.
So it all started by looking up at the stars. That's kind of beautiful, actually.
It is.
So poetic. Then we have Aristotle. He actually used real-world stuff to prove it. Like, he used lunar eclipses as evidence.
Aha. Smart.
So during an eclipse, right, Earth's shadow falls on the moon. And that shadow, guess what? It's always round.
Makes sense.
You can't make a round shadow with a flat object. No way.
Nope.
It's like Earth putting on a giant shadow puppet show to prove it's round.
I like that.
But wait, there's more. Back in 240 BC, that's like over 2,000 years ago, a guy named Eratosthenes actually calculated the Earth's circumference.
Really? How?
No fancy computers, no satellites, just sticks, shadows, and brainpower.
Wow. That's incredible.
And get this, his calculations were incredibly accurate. He used the angle of the sun's rays in two different cities and the distance between them. That's it.
That's incredible. Talk about thinking outside the box.
Total mic drop moment in science history. Makes you appreciate how smart those ancient thinkers were. And hold on, because it gets even better. It wasn't just the Greeks who knew about the round Earth.
Oh, really?
Yeah. Cultures all over the world, from ancient India to Islamic scholars, they all figured it out independently.
Huh. So it wasn't just a Western idea then?
Nope, not at all. Different cultures, separated by huge distances, all came to the same conclusion. Earth is a sphere. It shows just how curious humans are about the world and our place in it.
It is a pretty fundamental question, isn't it?
Totally. And that curiosity, it's what fueled some of the most daring adventures in history.
Oh, like what?
Like Ferdinand Magellan's epic voyage. The first circumnavigation of the globe. We're not talking theory anymore. Someone actually sailed around the entire planet.
Wow. So in the early 1500s, Magellan's journey finally put that whole flat Earth idea to rest.
Pretty much. It proved without a doubt that you could sail west and end up back where you started. Something you can only do on a sphere.
Makes you wonder how anyone could still think it was flat after that.
I know, right? And his voyage led to better maps and globes, too, which showed Earth's true shape more accurately.
Right.
Okay, now picture this. You're at the beach, watching a ship sail away. Ever notice how it doesn't just get smaller and smaller? The hull disappears first.
Right.
Like it sinks below the horizon.
Yeah, I've seen that.
That wouldn't happen on a flat Earth. You'd just see the whole ship getting smaller and smaller until it was just a dot.
That's a good point.
That's one of the simplest but most powerful pieces of evidence we have. It proves that Earth has to be curved.
Simple, yet effective.
Right. And there's more. Have you ever thought about the stars?
Yeah.
The constellations you see actually change depending on where you are on Earth. You see different stars in the northern and southern hemispheres.
Right.
Try explaining that on a flat plane. It just doesn't work.
You got me there. The way stars appear to move only makes sense if Earth is a rotating sphere.
Exactly. So we've got ancient philosophers, brave explorers, and everyday observations all pointing to the same conclusion. Earth is round. But get ready, because modern science takes this to a whole other level. So we just talked about how even ancient civilizations figured out that the Earth is round, but now we can actually see it.
Oh, yeah.
We have pictures of our planet from space, like actual photographs.
It's true. Satellite images give us undeniable proof, visual proof of Earth's curvature. Organizations like NASA, they have so many images showing our planet's round shape.
I know, and they're so beautiful, those photos from space.
They are really something.
And it's not just pictures either. Think about those astronauts on the International Space Station. They see the curve of the Earth every single day as they orbit.
Oh yeah, for sure. Astronauts describe it as a really moving experience to actually see Earth from space. It kind of changes your perspective. You realize we're all on this one little planet. And it really hits home that it's a sphere.
I bet. Okay, let's get back down to Earth, literally. What about gravity? It plays a huge role in shaping planets, right?
Oh, absolutely. Gravity is this force of attraction between any two objects that have mass. Basically, the bigger the object, the stronger its pull.
So that's what keeps us from floating off into space.
Exactly. Earth's gravity pulls us towards its center, and that's where Earth's shape comes in. That pull coming from every direction is what shapes planets into spheres.
Hold on, so it's not just a coincidence that planets are round. Gravity actually makes them that way.
You got it. Gravity's like a giant sculptor. It molds huge objects into the most stable form, a sphere. It's the same reason why soap bubbles are round.
Wow, I never thought of it that way. So gravity is shaping the entire universe. That's wild. But here's the thing that blows my mind with all this evidence. Why are there still people who believe in the flat Earth? Like, why?
Yeah, it's a tough one. I mean, it kind of makes sense that ancient civilizations thought the Earth was flat. They didn't have all the knowledge we have today. But now, it's a little harder to understand.
So why do they hold on to this idea? What's the deal?
Well, one reason might be the way our brains work. We humans tend to look for information that agrees with what we already believe. It's called confirmation bias.
So if someone believes in a flat Earth, they'll only pay attention to stuff that supports that, even if it's wrong. They just ignore the rest.
Pretty much. They might stick to certain websites or videos that reinforce their beliefs, and they won't even consider anything that challenges those beliefs.
And then there's that whole distrust of authority thing. Some people just don't trust scientists or the government, for example.
Right. And that distrust can lead people to look for different explanations, even if those explanations don't have any evidence or go against what we know from science.
It's like they want to believe they have some sort of secret knowledge.
Exactly. Feeling like you're in the know, like you've got this secret that most people don't, that can be really appealing. It makes people feel special. And it makes it hard to accept information that challenges that feeling.
Okay, let's tackle some of the arguments that flat earthers use. They often say that you can't see the Earth's curve. But what about those pictures from space?
Yeah, but some people will say that those images are fake, that they're just made up or edited to show a curve that isn't really there.
Oh, I see. What about that whole fisheye lens thing? They claim that the curved horizon you see in pictures is just because of the camera lens.
That's another one. But it's not true. Fisheye lenses create a very specific type of distortion, and it's pretty easy to recognize. The curvature we see in images from space, or even from high-altitude planes, it's not a distortion. It matches up with Earth's actual shape.
So what can we do to help people see the truth? How can we encourage them to think critically about it?
Sometimes the simplest things work best. We can encourage people to try some basic experiments. They don't need any special equipment. They can just watch a ship sailing away and notice how the hull disappears below the horizon first.
Or they can watch a lunar eclipse and see that the Earth's shadow on the moon is round.
Exactly. Those are things that anyone can do. It's about helping people to think for themselves and question what they see and hear.
So it sounds like education is really important here.
It is. We need to make science education more accessible so people can understand the world around them better. There are a lot of great science communicators and online resources that can help with this.
Yeah, for sure. So how can we become more media literate ourselves? Any tips?
It all comes down to questioning everything. Don't just accept what you see or hear online, especially if it sounds too good to be true. Check the sources, look for evidence, and remember that emotions aren't the same as facts.
And it's good to look at different viewpoints and challenge your own beliefs.
Right, absolutely. Being open to new information and changing your mind when you learn something new, that's a sign of intellectual honesty.
Are there any specific websites or YouTube channels that you'd recommend for learning more about space and science? I think I need a refresher myself.
Oh, definitely. There are tons of great resources out there. Like Name of YouTube channel 1 does a fantastic job of explaining complex topics in a way that's easy to understand.
Uh-huh.
And then there's Name of YouTube channel 2. They use humor and animation, so learning about science is actually fun.
That sounds awesome. We'll make sure to share those links in our show notes so everyone can check them out. Speaking of checking things out, we've got one last question for you before we wrap things up in part 3.
Yeah.
Ready for it? Okay, so here's something to think about.
Hmm.
If we can be so wrong about something as basic as the Earth's shape,
Hmm.
right? What other things might we have wrong?
I see what you mean.
Like, what other stuff do we believe without really questioning it, just because it fits with what we think we know?
That's a really good question. It makes you kind of step back and look at everything.
It's like, are we taking other things for granted?
Yeah, exactly. It reminds us to be open-minded and always keep learning.
It's easy to just accept what we've always been told, but maybe we need to be a little more curious about the world.
For sure. Knowledge is always changing, so we should never stop learning and questioning things.
Exactly.
Yeah.
So what's the big takeaway from this whole deep dive into round Earth versus flat Earth? What do you hope our listeners will remember?
Well, I hope they see how important critical thinking is and
Mm.
how important it is to look for evidence. Don't just believe everything you hear.
Yeah, question everything.
Right. Don't be afraid to challenge what you think you know and be open to new ideas.
And remember, the evidence for a round Earth is like super solid. From ancient times all the way to modern science, it all points to the same thing.
It's pretty amazing when you think about it. All that evidence, all that history, all pointing to one conclusion.
It's not just about knowing the facts, though. It's about understanding how we got to those facts. The process is just as important.
Definitely. It's about appreciating science, and how we use evidence and logic to figure things out.
So, next time you hear something that sounds kind of crazy or maybe too good to be true, remember this conversation.
Ask yourself some questions. What's the evidence? Where's this information coming from? Is there another side to the story?
Don't just accept things blindly. Do your own research.
Exactly. And don't be afraid to change your mind if you learn something new. That's how we grow.
Totally. That's all for this deep dive episode. It's been awesome exploring all the evidence for a round Earth.
It has, and we busted some myths along the way, too.
Always fun to debunk some conspiracy theories. And hopefully we've inspired everyone to keep being curious and to never stop learning.
That's what it's all about. Curiosity and critical thinking, those are the keys to understanding our world.
So until next time, keep those minds open, keep asking questions, and we'll catch you on the next deep dive.